Hey y'all, this is part 2 of the density stuff for Monday the 26th. If you haven't seen the notes one yet, go back, check the notes one. It's got a lot of important stuff in there about doing unit conversions. That's something that we might need to practice more when I get back. It's super important, it's super useful if you're doing anything in math, engineering, especially in science, anything remotely related to the medical field, whether you're trying to be a nurse, doctor, physician, physician assistant, anything like that. All this stuff super important, so it's stuff we're going to want to know. But all that to say, go back, watch the notes if you haven't. So this is for the practice problems. I'll just do a few of those, get y'all started on that. And then again, if you have questions, you got to let me know. Reach out to me. I will respond probably within a few minutes, if not faster than that. Anytime during the school day, I'm always on my phone, my computer, so text me, email me. All right, let's go. This first one here, so we got a block of aluminum. It occupies a volume of 15 milliliters and it weighs 40.5 grams. What's the density? So if you watch the notes one, which you should have by now, we got the formula density equals mass over volume. So this one is a lot easier than what we saw in the notes. Just straight up plug it in. So we got a mass. Mass is how much does it weigh, right? So 40.5 grams. And then the volume right here, 15.0. So 15.0 milliliters. So this one is about a 20-second problem. You're going to do that division. That's it. That's your answer. So 40.5 divided by 15, that's going to give you 2.7 grams per milliliter. There's your density. Cool. That's all there is to it. That one's pretty straightforward. Number 2 looks like actually it's the same thing. Yeah, it's just the same thing. Divide the mass by the volume. That's it. All right. Number 3. All right, slightly different here. Right, this time they ask us to find the weight. So that's like that mass. You're looking for the M in that equation. So we got density equals mass over volume. All right, so we got density, or this time, this time they gave us the density. Right, so our density is going to be 0.789. So in place of that D, let's write 0.789 equals, and then it's asking us to find the weight. So we're solving for M. So we don't know what M is this time, but we do know V. There is something we can plug in for V down here, and that's going to be 200, right? 200 milliliters. So we got our 200 down here, right? Great thing again. It doesn't ask for any specific units, so we don't need to do any of those big, long unit conversions that we saw in the notes. All we got to do, multiply that 200 over to either side, and you will be good to go, right? Multiply by 200. That cancels over here, gets the M all by itself. So we got 200 times 0.789, and that's going to give you 157.8. equals the mass. And what units were we in? As far as the units, I'm going to rewrite this with the units in, because that actually might be a little helpful. Because if you try to remember what are the units, it looks like we're in grams, just because I noticed that grams is the only unit of weight here. Technically, though, I want to demonstrate something, so I'm going to rewrite it with the units just so you can see something, because this is important. All right, so we have that 200, right? That 200 was milliliters. Right, because that came from this right here. That was in milliliters. That was a unit of volume, right? It's telling us like how big that container is. And then that 0.789 was grams over milliliters. It was a measurement of density. So I have 0.789 grams over milliliters. And remember, we were multiplying that 200 on either side, right? So it was 200 milliliters. Well, notice what's happening here. Now, I've got milliliters here, and then I've also got a milliliters in that denominator, right? The grams over milliliters, that comes from this right here, that density. So that is canceling out, leaving us with 200 times 0.789, which gives us this number right here. And our unit of measurement is grams, which is good because that is a measurement of weight. Grams is a weight, right? So that is our units for this problem, is grams. So 157.8 grams, that is the weight of the alcohol that fills this container. All right. This next one is asking about density. So, you know what? Here, I'm going to do, trying to think, should I do 4 or 5? I'll do 4, and then I'll quickly explain number 5. I don't want to do them all because I want to make sure you all get to practice them, and you can always ask me questions. I'm trying to figure out what would be most helpful. I'll do number 4, and then I'll quickly explain 5, but I'll leave it to y'all for the most part. So we've got dimensions of this block, right? 8.4, 5.5, 4.6. And we've also got our formula. Don't forget the formula. And we're looking for density, right? So that's mass over volume. And our mass is 1896 grams. Over, right? I'm substituting that for the m because that was our mass. And our volume, if you remember how to find the volume, it's length times width times height, right? That's these 3 guys right here. So go ahead, go in your calculator, multiply those together. 8.4 times 5.5 times 4.6. That's going to give you 212.52. And that is a volume. Notice these were in centimeters, right? So whenever you have volume, that's going to be centimeters cubed. Area would be centimeters squared. Volume is centimeters cubed. So area, they're always squared. But for these density problems, we're looking at volume, and that's going to be cubed. So we got cubed. All right. So that density that we're interested in is we got to do that division. So it'd be 1896 divided by 212.52. And that gives us a density of 8.92 grams per cubic centimeter, right? Notice that we're keeping that, keeping those units intact, right? The grams staying on top, the cubic centimeters on the bottom. There's nothing to cancel out the grams or the cubic centimeters. So that's going to stay where it is. So do the division, keep your units there. And again, because thinking about density, right? It's mass over volume. So it is some unit of mass, and then some unit of volume is still going to be in like that denominator of our final answer when we're finding the density. Okay, so there we go. 8.92 grams over cubic centimeters is the density there. Number 5, again, we're looking for density. So it's going to be mass over volume. The only difference, this one's pretty straightforward. They give us a volume right here. The only thing that you have to do to find the mass, right? Notice they give you the weight of the flask and the carbon tetrachloride together is this right here. And they also give you the weight of the flask. So when we want the actual mass that we're going to use, and when we set up this equation, we know what to plug in for the volume, right? That's going to be this guy right here. But when we're trying to figure out what to plug in for mass, make sure you take the total mass, subtract the mass of the flask, right? Because whatever you'll be left with, that's the mass of the carbon tetrachloride. So then it'll be mass over volume. That'll be your answer for the density. Okay. I'll leave the second page to y'all as well. But please, you've got to reach out to me if you have questions. I can't do all of it because then there'll be nothing for y'all to practice, and I'll take up the whole class yapping on these videos. So good luck, but you got to reach out if you have questions. I really hope to see y'all soon. I'll keep you all updated.